Today we will be talking about calorimetry, the experimental process in which we can find the change in enthalpy for any given reaction. Before we can solve for this, we must first know what the general equation for calorimetry is. This equation is stated below as saying that the change in enthalpy equals specific heat times change in temperature times mass. Also, we need to keep in mind that the Q of the solution is equal to the negative Q of the reaction. There are two things that the reactions can be. The first is endothermic, meaning that Q is positive, or also that it could be exothermic, meaning that Q is negative. The lab that White and I are doing is a basic one in which NaOH is being dissolved into water. Then after collecting our data, White will solve for the change in enthalpy. But first, here's a photo of the setup with the NaOH being mixed into the H2O inside of a coffee cup.
These are the calculations for the calorimetry lab seen earlier in our video, and what we'll be demonstrating is how to calculate the heat of the solution for our salt NaOH, using our fancy data table here. The first step is to write out a balanced thermochemical equation, like the one seen here, showing how the solid sodium hydroxide is dissociating into its ions sodium and hydroxide. The general equation for a calorimetry problem like this one is Q of the solution is equal to the specific heat times the entire mass of the solution, which includes the mass of the solid dissolved, times the change of temperature. Now, the specific heat of our solution water is constant at 4.18 joules per gram degree Celsius, so we only need to find the change of temperature and the mass. To find the change of temperature, we simply subtract the initial temperature of the water from the final temperature of the solution. Doing this, we see that we get a change of 16.1 degrees Celsius. Next, to find our mass, we add up the mass of the water, 75 grams, and the mass of our ionic solid, 5.62 grams. Doing this, we get 80.62 grams, and now we have all of our values for our Q of the water equation. Plugging in our values, we get 5,425.6 joules. The next step is to find out Q of the reaction. Q of the reaction is negative Q of the solution, because whatever heat the solution either gains or loses must have been the same value that the reaction lost or gained. So, doing this, we know that Q of our reaction is negative 5,425.6 joules. Now we're on to the last step. Alright, to calculate the heat of the solution, we need our answer in kilojoules per mole. Now, to get per mole, what we'll do is divide our joules by the amount of solid sodium hydroxide dissolved into our water, which is 5.62 grams. Then we'll multiply by the molar mass of sodium hydroxide, 40 grams over 1 mole, and we get negative 38,616.12 joules per mole. Now, to get kilojoules, we simply divide by 1,000, getting our final answer of negative 38.616 kilojoules per mole. Now what we'll do is calculate our percent error from our calculations. Percent error is simply the actual value minus observed value over the exact actual multiplied by 100%. The actual value of sodium hydroxide is negative 44.45 kilojoules per mole. Plugging in the actual value and our observed value of negative 38.616 kilojoules per mole, multiplying by 100, we see that we get an error of 13.12%, which isn't bad, but could be better. Now for the last part, we're showing you an enthalpy diagram for this reaction. So, we know that our reaction was exothermic because it was a negative value. So, this graph shows how the solid sodium hydroxide reacts in the solution and goes down and turns into the aqueous sodium hydroxide.
So this is a typical AP question that could be asked that involves calorimetry, and here are some of the things that it may ask you to find. And then, so the first thing it wants us to do is find or give the appropriate units for each of the term in the given equation Q equals M times C times change of T. And with the given information above, we find that Q equals the mass in terms of grams, the change in temperature in terms of degrees Celsius, and the specific heat in terms of joules per gram degrees Celsius. And then the next thing that it wants us to do is list the measurements in order that must be made in order to obtain the value of Q. These would include the change in temperature, the mass of the reactants, and then you would need to look up the specific heat for HCl or NaOH if it wasn't said that you could use the specific heat of water. Now, it wants you to find the number of moles of water formed in the experiment. And with this, you can find this out by knowing that moles equals volume times the molarity of NaOH or HCl, doesn't matter, they're equal, times the moles of H2O over the number of moles of NaOH, which is a 1-to-1, meaning that there's only 1 mole of H2O produced. Now also, it wants you to figure out the steps in how you can solve for Q or the change in enthalpy. To do this, you first need to find the Q of the water, and then remember from earlier in our lesson that Q of the water equals negative Q of the reactants. Now this gives you an arbitrary number for the change in enthalpy for the number of grams that you were using. So now to figure out what it would be for like per mole, you would go and divide the Q of the reactant by the given number of grams and times that by number of grams in 1 mole of HCl or NaOH to find out the change in enthalpy per mole.
Whoa! What?